Thanks everyone for coming to this event. So today we are going to talk about VPP and what is a TLS plugin inside VPP and how we have optimized it for better performance. So today me and Varun are here who will go through the presentation. So my friends from VPP community has already given you introduction on VPP. I will not go deep into the VPP internals, but just a question to everyone. So how many of you have had CPU architecture in your university class or somewhere, right? Right, yeah. So I see a lot of people. So one just statement I want to mention is that VPP is one of the softwares which leverages very basic concepts of CPU architecture. Like everybody says that, okay, you need to have data in L1 cache or instructions in L1 cache, right? Okay. How many softwares make sure that you always have your instructions or data in the L1 cache before you actually execute the instructions, right? So this is, from the programmer's point of view, I feel that VPP is one of the very few softwares which leverages this and gets the best performance out of your software. Okay. So yeah, we'll move on. So the agenda is that we'll go over what TLS plugin is and what are the contributions we have done to TLS plugin which enhances its performance. And we will also briefly mention about DPDK user space crypto driver, because we internally leverage DPDK for enhanced crypto performance. And Varun will provide what is the actual functionality we have implemented to increase the performance. And we have some performance numbers comparison and what is the future scope of the work we are going to do. Okay. So what is VPP TLS plugin? Okay. So as earlier sessions has already mentioned, right, everything in VPP is a loadable plugin. Okay. So even the TLS functionality in VPP is a loadable plugin. Okay. So TLS is a transport type which is exposed by VPP framework. Just like you want to say that I want to do a transport socket of TCP type or UDP type, right? Similarly, in VPP, you can just say that I want to do a data transfer with the transport of TLS. So you just go and write to this socket, and the underlying TLS implementation will encrypt the data and then send it out. Right. So it also provides integration with multiple TLS libraries. Some of the examples are OpenSSL and Pico TLS and Embed TLS. For the scope of this talk, we will concentrate on the OpenSSL because that's where we had done some tests and performance comparison. And in VPP TLS plugin, we have the session management which is done within the TLS plugin, so that any application data which is sent to the TLS layer will know what kind of TLS keys to be used and keys, and then what is the underlying TCP connection on which you have to send the package. So it also provides some configurability on what are the keys and certificates you have to use for the data application data. So going over the contribution which we have done to TLS plugin. So for those who are aware of OpenSSL software, there is it's not very recent, but in earlier OpenSSL they have introduced a concept of asynchronous crypto jobs. So we have leveraged that and then adapted the same thing into the TLS plugin, where you can have a crypto job. Let's say you want to do a RSA sign operation. So you can go and submit the instruction as an asynchronous job. You don't, if there's an accelerator which can work on the other side, you don't need to wait for the operation to complete. The core comes back and it can do the application work. And then after some time, if you go and check if the crypto operation is done, you can go receive the response and then complete the overall request. Okay. So that way we can save the time in which the RSA operation is getting done or any crypto operation is getting done. So we have also, after adding this, right, we have verified this functionality with Marvel OpenSSL Engine, which we have written so that we can leverage the hardware accelerator capabilities of Marvel's DPU. So these are the patches we have pushed to add the performance enhancements. Okay, we can go over it later. So the Marvel OpenSSL, which I have mentioned in the earlier slide, it internally uses DPDK crypto PMD. So basically what it does is it goes and submits instructions using the DPDK RTE APIs, and then the underlying PMD will take care of the submission to the actual hardware. Okay. So just brief introduction on DPDK user space crypto device, why it is faster. It works on the PMD basis, so there's no interrupt handling or interrupt context switches, so the performance will be higher because of that. And asynchronous processing, so it allows you to submit the instructions asynchronously, and that too you can do it in a burst basis, so that if you want to do 10 requests at a time, you can go and submit 10 requests and then go back, do your work, do your application work, come back and see how many are done. Once if X number of requests are done, you go and resume those operations. And it also provides flexibility because there is a software OpenSSL based crypto implementation in DPDK, so you can have a comparison against your hardware accelerated PMD versus software OpenSSL crypto implementation. So that way you can say, okay, my implementation is like X percentage better than the software based implementation. And also we maintain session within the engine, so that for a certain session we don't need to set it up multiple times. So basically if you have hundreds of packets flowing through the same session can be used once it is set up first time. And it's a standard API, so instead of saying that okay, if you are moving from one implementation to another implementation underneath in the DPDK, you don't need to change your code much. So Varun will take over here, and then he'll explain what is the actual work done at the code level.
Yeah. So this particular flow is explaining how the TLS plugin handles the TLS processing. So whenever the TLS plugin, which acts as a server, receives any TLS traffic, will see the request type, and it will send it to the OpenSSL engine using the SSL library calls. So the underlying library will check if the asynchronous mode is enabled or not. If it is enabled, then it checks what is the return value of the API. If it says I want async, then it passes the request to the next level, which is a Marvel OpenSSL engine, which internally enqueues the actual process to the hardware, where the actual work will be done. And once the work is done, the hardware accelerator will respond back to the engine saying that the job is finished. Where in the TLS plugin will continuously poll the engine for the asynchronous request completion. Whenever a request is completed, we'll get a callback, and in the callback we'll see what kind of event that was completed. So we are maintaining two different queues, one for the handshake messages and the other one for read and write events. So based on the event type, the particular event will be enqueued into the respective queue, and it goes for the next level processing in the plugin. So in this way, the plugin will keep polling the engine, and in the next iteration, what it does is it dequeues the queues and it processes the event based on the handler which was written for the particular event type. So there the actual work will be done, and it completes the request and it will send the response back to the application. So here the TLS plugin acts as a server and it will respond back to the client. So this particular flow is showing the same thing. Yeah, these are the performance comparison numbers which we have captured with the software and with the hardware acceleration. So on the left hand side we can see we have tested with 1 and 2 cores with different file sizes. On the right hand side we can see the hardware accelerator performance. And the test setup is it's a simple DUT which is connected back to back to a traffic generator, where it sends the packet and it gets the encrypted decrypted packet outside. So we could see that the software numbers with with software we are able to achieve up to 6 or 7 Gbps up to like with different file sizes, whereas in hardware accelerator the performance is much better than the software one with the asynchronous mode enabled. And the testing conditions are mentioned in the slide. We have used RSA 4K, and the queries per second improvement that we observed was approximately 20%. And when we are submitting this particular asynchronous processes to the hardware accelerator, we saw an improvement of up to 50% in the CPU utilization, like where the CPU was free for processing something else in the VPP context. Yeah, we also introduced this pipeline feature in the recent patch. So these are the numbers with different pipes with the different record sizes. So what pipes means, like we can configure n number of pipes where a particular record will be given to those many pipes, and the hardware will process those many pipes of packets in parallelly. So here we can see the performance with the different number of pipes configuration. Okay, so what we see here is like we expected much better performance with larger number of pipes, but it was not observed in that way. But yeah, this is something which we will be taking as a future scope. Okay. Yeah. So these are the future scope that we are planning, where we are planning to upstream our OpenSSL Engine to the Marvel as a to VPP as a separate plugin, and also we are planning to give the provider support in the TLS plugin, and optimizing the performance with multiple workers and multiple pipes. These are the things that we are planning in the future.
So along with TLS, we have multiple data plane based accelerated solutions which can work on Marvel DPUs. So we have an open source GitHub repo where people can directly go and look what are the solutions we are providing on our DPU. So we call it as Marvel DAO, Data Acceleration Offload Git repo. Okay, so there are multiple solutions based on DPDK, VPP, OVS, and AI/ML related solutions. So this is a GitHub repo. So if there is anybody who is interested in data plane networking solutions for it, there are some cool solutions. You can try it out. You cannot expect on a small hardware like a DPU, like you can achieve like 100 Mbps of L3 forward application, right? So you can just go over it, try it out. If you have any issues or any ideas, we are ready to help and work on it. Okay. Yeah, that's all we had. Thank you.
Any questions?
Hi, thanks for this work. Just a quick question. Are you relying on the crypto async framework in VPP, or is it your own type of framework, your own type of engine that you implemented with Marvel?
Yes, so this is a TLS implementation based on OpenSSL, right? OpenSSL has its own internal async crypto framework.
Okay, so you created an async framework for OpenSSL, not for not
right,
in VPP.
Right,
okay.
Right.
Okay, thanks.
Okay, thank you very much.
Yeah, thank you. Thanks, everyone.